Cyclization by tributyltin hydride. Tin compound. Tributyltin hydride is an organotin compound with formula C4H9 3SnH. Organotin hydrides are very good radical reducing agents due to their relative weak non-ionic bond between tin and hydrogen. That is, Bu3SnH is a weak bond with 74 kcal per mole energy that can cleave homolytically and easily. Here, the tin hydride SnH bond is a very weak bond. It can cleave very easily by forming a free radical, thereby forming the product. SnH is a weak bond than CH bond. Hence, it requires an initiator molecule, that is AIBN, Azobisisobutyronitrile, that is to break the SnH bond. We require an initiator molecule. Next one, RBr with Bu3SnH AIBN gives RCH2H. It's an alkane. Alkyl bromide gives alkane. This is initiated by the AIBN, is an initiator molecule which forms a radical plus nitrogen. This gives on cleavage gives a radical. This gives the propagation step. This radical again reacts with the reactant RBr. Will get a radical again. Again this radical reacts with Bu3SnH, and this is a propagation step, and finally we get the product. So intermolecular addition reaction. Here the Ci bond, C iodine bond, is a very weak bond which can be cleaved very easily. Here ester, we take ester, tributyltin hydride is given as TBTH, AIBN, in presence of AIBN initiator molecule. We will get the product like this. It is an intermolecular reaction. Similarly, R1 iodide with ester gives this molecule. Here you see, in this ester, the CCl normally cleaves is a very strong bond, is an electron withdrawing group. Chlorine is an electron withdrawing group is attached to this ester, which stabilizes the radical so readily formed. So this bond will be cleaved very easily because the electron withdrawing group was attached. So we will get the product. This one is the product. TBTH is it. Now we have to see intramolecular addition reaction. It's an intramolecular cyclization by tributyltin hydride. Intramolecular cyclization is a radical based ring formation reaction. Ring formation is preferentially 5-membered ring. Here we take 6-chloro-X1-ene. This can be written like this in a cyclic way, which are reduced with this radical SnBu3 gives this chlorine. This chlorine and the SnBu3 also removed to give the product alkene. In this alkene, this double bond is shifted by forming a carbocation. This vinyl radical, see, this vinyl radical is very less stable and more reactive than alkyl radical. So this reaction is favored by vinyl radical. This on cyclisation. Let us take this A, B, C, D, E. and the cyclization between A and E. A new bond is formed between A and E. And this will be the product, methyl cyclopentane. Here you see, it's A, B, C, T and E. A new bond, this bond is formed between A and E. So methyl cyclopentane is the product. Let us take the same reactant 6-chlorohex-1-ene. This reacts with Bu3SnH in presence of AIBN. You will get the product you have seen already. Suppose you take the same reactant, react with AIBN in excess of Bu3SnH. What happens? What will be the product? Now the product is 6-chlorohex-1-ene. Now the cyclization will not be formed. No ring formation. No ring formation will be formed. Now this chloride Cl bond is replaced by CH bond. So in excess of the catalyst Bu3SnH, the reducing agent. If the reducing agent in excess, you remember no ring formation occurs. If this Bu3SnH was not in excess, the ring formation occurs. So just remember this one. This type of questions are asked mostly in many competitive examinations. And let's see that what will be the product. The product formed will be the 5-membered product rather than 6-membered ring. Now the product, see this product formed is a 5-membered ring. Now behaves like an halide, and here also a 5-membered ring is favored. Here this is the product. Here also the 5-membered ring is formed. Here the radical reacts here to give the product, and here in this alkane will be the product. Let us take this reactant. In this reactant, a reaction occurs, the cyclization occurs between the triple bond and CBr. The CBr bond will be cleaved and a ring formation occurs, and a 2,5-exocyclization occurs. That is, the 2 5-membered ring has been formed and a double bond bridges between the 2 5-membered ring. It's an important reaction. Let us take 2-iodo-2-methyl propane. This we are reacting with tributyltin hydride. What will be the product? And this will be the product. Let us take the same. It's an initiation step. You see this catalyst, this radical reacts here, and the Ci bond is cleaved and the initiator molecule, the propagation step. This will be the propagation step. Reacts with the reactant to form another radical. This again cleaves to give the product. Now let us take 1-methyl cyclohex-1-ene. Now what will be the product? 1-bromo 2-methyl cyclohexane will be the product. Here no cyclization occurs. Just the double bond is reduced.